Hello everyone, welcome to Experiment 1's Safety Talk. In Experiment 1, the idea is all about observing changes and linking that to theoretical chemical changes. So for example, if we see a color change, to what kind of metal oxidative state can we link that? So if you have a manganese salt and you see that the manganese or the salt changes color from green to purple, what oxidative state, or maybe from colorless to purple, what oxidative state of manganese is present in either case? So the main point here is for you to make careful notes and see if you do what, meaning if you change from acidic to basic medium or have no medium, let's just say, or neutral medium, what is the effect on what you can observe? Is there gas evolution? Is there a color change? Is there release of heat? Is there absorbance of heat? So make notes of everything that you see. It kind of tries to or aims to teach you to make observations in the lab. It's our main goal. But unfortunately, or maybe even fortunately, it comes with some risks. For example, we'll have to work with some lead nitrate, which can easily be absorbed through the skin. Of course, lead is a highly toxic metal, and in its lead nitrate form, it's fully dissolved and hence can be easily absorbed. Not unlike, for example, lead chloride, which struggles to dissolve. But anyway, you'll also be working with oxidizing and reducing agents, which will devour your gloves. It's an eye irritant, a skin irritant. Um, it is something to watch out for and just be cognizant of. Keep on checking that your gloves are still completely intact and that you do not touch your face, do not touch your glasses, especially if you take off your glasses or your lab goggles or go out to eat. Ensure that you remove the gloves and take a fresh pair when you come back into the lab, especially in experiment 1.2. You'll also be working with something called ammonium metavanadinate, which is a chemical or central nervous system depressant. Now, essentially, it can paralyze you. It can hamper your breathing, and overall a very bad experience. Now, its active level or toxic level is about 5 grams, so it should not be. It's highly unlikely that you'd ingest that much in a single dose, but it's not something that you should be ingesting at all. It can be quite volatile or not volatile. It can, so please be careful with it. Always work with any chemical in the fume hood. Do not weigh anything outside of the fume hoods. Do not work with any volatile liquids outside of the fume hood. Measure everything in our dispensing fume hoods. And if you have to transfer something between fume hoods, ensure that you cover it with a watch glass or at least with your glove. So that if spillage or volatilization happens, there is some coverage. Right. General advice is if there is a spill on your lab coat, gloves, or etc., rinse thoroughly, act quickly, and remain calm. You won't die within the first few seconds, but as long as you act quickly. And as well, as long as you wear your goggles, your lab coat, and your gloves, you will be fine. Okay. Now, experiments 1.4 and 1.5 are virtual experiments. So these are experiments meaning that you will have to do some research on them and find your own experimental videos to watch. You will not be completing them in the lab. You will do some research, read up on them. There are some additional resources provided for them. But a good place for you to start is, like I said, watch a few YouTube videos and make your own observations. And I give you some threads to plug into Google for both of them. For experiment 1, the thermal decomposition of ammonium dichromate, and for experiment 1.5, potassium sodium tartrate and hydrogen peroxide catalyst reaction is a good start. You should find exactly what you're looking for. You can make your observations from there. It gives you an opportunity to delve a bit deeper, see what's out there, learn how to discriminate between nonsense that's on YouTube and available on the internet, as well as um, see some cool things and see multiple sources for the same thing. All right, thank you for watching, and I'll see you in the lab.